Hello everyone, welcome again to my channel. In this session I want to talk about contentions related to object allocation in Tempdb. Let's get started. Let's suppose we have this user running this select int query to create temporary table called T1. So what happens internally in SQL Server when user runs this query in SQL Server, right? Let's see this example firstly from SQL Server 2014 version. We will touch other versions also, no worries. When user initiates request, it first reaches protocol layer of SQL Server, and after successful network negotiations like TCP protocol, TCP negotiation, TLS or something, the request touches CMD parser where query is checked for syntax mistakes. If everything is okay with your syntax, the query is passed to optimizer where the execution plan is generated, and based on this plan, query executor executes query. To execute query, query executor connects access methods, then buffer manager, and buffer manager here does many operations. Okay, we are coming to interesting point. First, it connects to buffer pool in memory to scan and bring all the data pages from this all objects DMV. Okay. You can see here, SQL Server is listing and preparing all the data first before inserting them to temporary table. Here you can see pages, right? What is page? Page is 8 kilobyte structure where data rows are located. You can see here page header, data rows, and if page has free space here, right? Pages are organized in structure called extents, and each extent can consist of 8 pages only. Extent can be full, half empty, or completely empty. Also, extents can be uniform extent or mixed one. If all the pages in extent belong to a single table or object, we call this as uniform extent, like this extent A. But if extent consists of pages from different objects, we call this as mixed extent, right? I know that you know these things, but just in case I'm repeating. Okay, now we listed all the data rows to insert to temporary table. The next step is we should insert these rows in pages to temporary table. If you want to check this step by yourself, right? These steps by yourself, you can just enable actual execution plan like this and execute query. You can see here, we are firstly bringing all the data from these objects, filtering, hash matching with this single object refs table, right? Different system tables. Then hash matching is happening with these file names. Finally sorting and bringing top 2015 records. Now we should insert these records to temporary table. For this, SQL Server opens available temporary database file. You can see this file from your Tempdb properties. Every file firstly consists of system pages to manage data pages. These are file header page, PFS page, GAM page, SGAM page. These system pages track data pages in extents in the same file. PFS tracks free pages, GAM page tracks allocated extents, and SGAM page tracks which extents are mixed. There is one more important point here. There are some internal system objects in Tempdb to control temporary objects. You can use this query to get these objects. You can see most of them are internal and system tables. Pages which belong to these objects are also located in the file, okay? Then you can see user data pages. There they can be more than one PFS, GAM, and SGAM pages depending on the file size you have, okay? If you have big file, we need more PFS, GAM, and SGAM pages to control all this big data, okay? It means you have bigger file, you have more system pages, okay? Now, how SQL Server inserts data to this file? For this, it scans PFS, GAM, SGAM files and tries to find a suitable extent and pages to insert data. While scanning these pages, it takes shared Pagelatch. based on these pages, it will find a suitable extent and data page. Okay. For example, let's say the chosen one is this extent and this data page. Then temporary table is created and data will be moved to this extent and pages. Very interesting, right? But important point here. While data is being filled to this extent, SQL Server should also change PFS, JM, and SJM pages to reflect this data change. Okay? We should record this, right? This data change in system files also. To do this, SQL Server has to change this shared latch to exclusive latch. At the same time, it must also change system object tables while this change is happening. Therefore, it also takes exclusive and shared latches on system object pages. Okay? This is very much important. Now you can see two potential places where a latch contention might happen. If another user connects to SQL Server, runs the same or similar query to create temporary table, drop table, right? SQL Server should do the same operation and take latches. And these latches can be in these two places. As a result, this second user might be blocked and this second query might become slow facing latch conflict. If latch conflict happens here, we call this as object allocation contention in Tempdb. If conflict happens with system objects pages, we call this as metadata contention. Okay? So we might have two types of contention: metadata contention and object allocation contention. We will talk about how to troubleshoot this object allocation contention in this session, and in the next session, which I'm going to do tomorrow or after tomorrow, I'll share how to troubleshoot this metadata contention. So, to reproduce Tempdb contention, I install SQL Server 2014. You can see my instance name, instance 2014, right? So, if I select at version, you can see SQL Server version I have. Now, let's reproduce the high load. For this, I use OS Stress tool. OS Stress. This is publicly available. You can also download it by yourself. If you go to internet, and you will be able to find RML utilities for SQL Server. And if you click on Microsoft Download Center, you will be able to download this RML setup MSI file. After installing this MSI file, you will go to, for example, you'll go to this, let's minimize this one. You will go to C disk, program files, Microsoft Corporation, RML utilities. Here we go, OS Stress exe file. Okay, we will run this tool. For this, I go to CMD. Here is that tool. Okay, in the same location. So what does this tool do is it will connect to SQL Server instance and run this query. Okay, then it will drop table. This query is creating temp table, right? By bringing the data from sys all objects. Then it is dropping the table. And I'm running 300 sessions in parallel. And each session is running this query 100 times. Okay, 100 times. So let's run this tool and create stress for SQL Server. So for this, I run one thing, SQL exec sp who is active. Okay, and run it. Okay, let's wait a little. This is very much useful storage procedure I created by using the GitHub link. You can go to GitHub. For example, here we go. You can search by sp who is active, right? And go to sp who is active GitHub link. Go to this release and you just get the source code and you run it and you create this sort procedure. Okay, so I created it. As you can see, I'm facing many PFS related weights, right? PFS, all of them PFS. Okay, you can see that. And there are also GM related weights, right? This is the issue. Okay, many PFS related weights. And there are other weights related to this, right? There is no any kind of PFS or GM. This is related to this internal tables, system tables, pages. Okay, while we are taking Pagelatch for this kind of pages, we just mark weight info like this. Okay, so here we can see PFS related Pagelatch contention, GEM related Pagelatch contention, and at the same time metadata system table page related page contention, right? So we will concentrate on troubleshooting this PFS and GEM. Let's try to make this latch contention as less as possible. How to deal with this kind of Pagelatch contention? Firstly, you should increase data files. The more files you have, the more PFS, JM, and SJM pages. Okay? All the files must be equally sized. Secondly, enable trace flag 1117 so that requests to PFS, SJM, and JM are made in round robin to different files. Okay? Thirdly, enable trace flag 1118 so that extents are created only in uniform and we don't need to check SJM pages. In this way, you can decrease contention in Tempdb. Okay? Microsoft enabled these trace flags in SQL Server 2016 by default. Okay, do not forget. Therefore, if you have SQL Server version 2016 or higher, you don't need this trace flag. Okay, you don't need to enable these trace flags. It's already there. In SQL Server 2016 SP2 and SQL Server 2017 CU7, Microsoft made further improvement and added round-robin requests to different PFS pages in the same file this time, okay? Not in different... Before we enabled round-robin between files, right? Now, we as Microsoft enabled round-robin among the PFS pages in the same files. This significantly decreased PFS page contention and improved the performance. This is a summary of what we discussed until now. As you can see, by increasing SQL Server version, we can significantly decrease possibility of Tempdb allocation related contention. But you might still face it, okay? It is not completely 100% has been dealt with, okay? You might face in higher versions of SQL Server. In this case, you can deal with this problem by increasing number of data files only, okay? Okay. This is SQL Server 2014, the same server. Let me enable trace flags 1117, right? So, two trace flags enabled, both of them. And also, I will add several files, temp2, temp3, temp4, temp5, and temp6. Okay, let me change also the name of the file here. And let's create it. Okay? So it has been created, so let's confirm. Right click, properties, and files, right? And you can see I have many files now until 6. Okay, so let's try to again to make a load CLS. Okay, and let's see how we handle this time, right? So if you run SP who is active, right? Okay. So it finished very fast this time. You can see it finished here, okay? Weights is very much low. And if I again and check, it definitely increased. The speed increased and we faced less weights this time, okay? In short, if you have SQL Server 14, right? if you have that version, try to enable this trace flag and try to add more files. If you have higher versions, of course, you have all the options is adding these files. Okay? So I hope that you found this session useful. Thank you.